Today's problem is swap list nodes in pairs. This is on Interview Bid as part of their 12-week interview preparation kit. So you can go over there, pause the video, go over, try the problem, and then come back and we'll work through it. The difficulty is easy. It's I don't think you could rate it anything but easy, but it's a linked list problem. So with any linked list problem, just sketch a test case out ahead of time, and work through how the pointers are going to move, and yeah, you should be okay. Anyway, this is considered worth asking at Microsoft, Amazon, and this little thing here is Moonfrog Labs, which is a software company in India. It sounds like a fun place to work, Moonfrog Labs. Problem is given a linked list, A, swap every 2 adjacent nodes and return the head. Note, your algorithm should only use constant space. You may not modify the values in the list. Yeah, that would make it a little bit too easy. Only nodes themselves can be changed. Problem constraints. Size of the list will be between 1 and 10 to the 6, 1 million. All right, 1 is kind of an edge case, but we can handle that. I mean, it is an edge case, and it isn't in that. Well, we'll talk about that in a second. Let's see, input format. The input is a pointer to the head of the given linked list, and the output is a pointer to the head of the modified linked list. So we can't really do any swapping unless we have 2 nodes. So this input 2, for example, after we swap the first 2 nodes, we're going to find out that we only have 1 node left, and we're not going to do anything with it. So really the edge case is handled as part of the main loop. In other words, if we don't have 2 nodes, then we're not going to swap anything. So you can see here 7, 2, 1. We'll swap the 2 and the 7, but then the 1 is left as is. Anything else here? Oh, not really. All right. We'll use the first one as an example here. Let's see. Okay, whenever you got a linked list problem, and whenever you have a linked list problem and you can see that the value of the head pointer might change, you want to consider whether or not adding a dummy node to the head of the list is going to help you. And in this case, I think it is, because then you're going to have something that is not going to change. Now, in this case, we actually know that the head pointer is going to change. In fact, what we're going to return as the head pointer, because we'll swap the 1 and the 2, we'll swap the 3 and the 4, the head pointer is going to be pointing to this 2. It's not going to point to the 1 anymore. So let's look at the algorithm here. There's a little setup where we create a dummy node. We'll call it 0, 0. That node, the dummy node, will point to A. A currently points to 1, and current is the, we'll set current to the dummy node. I have a problem with representing this. It's like current. Okay, it's not like current.next is the dummy node. Current is the dummy node. All right, we've got to scroll this a little bit. Now that we've got the setup done, all right, here are the main steps. Loop, as long as we have at least 2 nodes to swap. So we're checking current.next for null. We're checking current.next.next for null. So that handles the 1 node situation, because If there's only one node, then current.next.next will be no. We'll drop out of here. We'll return dummy.next, which right now is A, the input. It never changed. We'll perform the swap, and then we'll move to the next pair. Okay, list node first is current.next. So that's this, 1. Second is current.next.next, which is this, 2. Perform the swap, all right? So first.next equals second.next. So this is first.next right here. So we're changing it. We're changing it to be second.next. Second.next points here. Second.next points to first. And current.next points to second. Okay. Before we do the next step, I think it would be less confusing to sort of clean this up and just point out that these nodes have been swapped. So this is now 2. This is now 1. And what is the next thing we do? Current.next equals second. Right? So again, I don't know, I just wanted a little bit there. Okay. Current.node, which is this, equals second. Well, actually, that's the same thing because second is the 2. Right? So that's right here. And then, now that's important. Let's do the next thing first. I'll come back to it. And then current equals first. All right. So current, if I can get rid of that, current equals first, right here. All right, good. Now we've disconnected current from dummy, and that dummy node is dummy.next is always going to point to the head of the list now. You know, we're going to keep swapping the rest of the elements. Current.next equals second. Okay. Yeah. So the thing is, well, actually, let's do this one more time because we're going to come through here again, and then we're going to say, all right, first is current.next, current points here. So first is going to be the 3. Second, current next is going to be the 4. The thing is, if your intuition on this initially is, well, I only need to keep track of 2 nodes at a time, that is incorrect. Because if we, so we've swapped the 2 and the 1, if we just move to the 3 and swap the 3 and the 4, that's fine, but we need a way to reconnect it back to the 1. The only way to do that is if we're also keeping track of the 1. So we have the current node, and we have what we're calling first and second. So you need to keep track of three nodes so that you can swap 2 of them and then reconnect those 2 back to current. Okay, so that's the loop, and let's run it and see what happens. Get rid of that. What is going on? Oh, okay. Yeah, good. All right. So thanks for watching. If you found this helpful, hit like, subscribe, check out the playlist on screen to keep improving your interview skills. Check the video description and the pinned comment for links to more resources, including a free LeetCode patterns cheat sheet, which you can download immediately, as well as a link to Code and Conquer, which is my complete coding interview prep course. And we'll see you next time.